Welcome to the Contagious Code podcast, where we dive deep into code, learn practical skills, celebrate the beauty of engineering, and eliminate imposter syndrome. I'm Tejas Kumar, and I've been building on the web for over 20 years at places like Vercel, Spotify, Zeta, and more. Today, my guest is Harper Carroll. Harper is an advisor and educator in AI to companies and individuals. Harper spent 10 years at Stanford studying machine learning, deep learning, and AI. And in our discussion, Harper's excellence and knowledge becomes very, very apparent. We go deep on machine learning. We talk about how machine learning works. We talk about input layers, hidden layers, output layers, and the end-to-end process. Harper teaches me LSTM, recurrent neural networks, etc., how these architectures are just different types of hidden layers. After spending some time on machine learning, we dive deep into AI engineering and explore the distinction between AI engineering and machine learning engineering. AI engineering being just talking to an API and machine learning being training models. If you want to be an AI engineer, you will never need to train anything. You can just talk to APIs. And Harper agrees with this claim. We also talk about RAG, a technique for bringing real-time context into machine learning models and bypassing hallucinations and context windows and knowledge cutoffs. And we talk about fine-tuning models for cost savings. And the cool thing is we talk about RAG and fine-tuning in the right context, meaning it's not RAG versus fine-tuning, but it's how RAG can complement fine-tuning. And these are just strategies for bringing inferences from large language models into the current era, so to speak, and well beyond their knowledge cutoff and minimizing hallucinations. We also talk about temperature. Finally, we talk about the future of AI as in the context of energy costs. We need a ton of compute, and nuclear is a great way to do that. Harper is releasing a series of content explaining how nuclear works in collaboration with a friend, and there's links to that in the show notes. It's a great discourse on the future of energy and AI. Finally, we just cast vision into the future. We explore Geoffrey Hinton's prediction for the future, which is in the next 25 years, there's a 50-50 chance that AI controls humanity. And we explore sort of the tension between the doomer viewpoint, that meaning everyone's not going to have jobs and AI is going to take over the world and it's all going to go bad, compared to the optimist or the hopeful outcome, which is AI does all the work. And we, like Copernicus looking at the stars or like Isaac Newton discovering gravity, we just get to dream and explore instead of running from this Zoom call to that meeting to this podcast and hustling as hard as we do. It's a great holistic discussion on machine learning and AI, a true deep dive with a true world expert. There's links to all of Harper's content as well in the show notes. Now, I'd like to offer this to everyone at no cost because this is super separate to my day job. I mean, look around, it's nighttime if you're watching on video. And the way we can do that is through partners and sponsors. Let's take a moment to acknowledge them. The Contagious Code podcast is partnered with Code Crafters. I have a style of teaching you how to code, if you know my style of teaching. It's like we build things from scratch, and that's what Code Crafters does. They have you pick a programming language like Python or JavaScript, and what they have you do is pick a tool like Redis or Docker or Jupyter Notebook, whatever it may be, and then you build it from scratch in the language you choose. By doing that, you get better at the language you've chosen, but you also get better at the tool because you literally build it from scratch. It's a great tool, and they offer you a generous free tier, but if you want to start paying, you can get 40% off using the link in the show notes. That's tej.as/codecrafters. The Contagious Code podcast is also partnered with SquiggleConf. SquiggleConf is a conference in Boston that celebrates developer tools. If you want to attend for free, share this episode on social media, say you want to do so, and you'll enter a raffle to win. The Contagious Code podcast is also partnered with React Africa. React Africa is a web engineering conference in Casablanca, Morocco. I will be doing the opening keynote, and it's a privilege to partner with them because we get to share in the joy of knowledge. If you want to attend that conference for free as well in Casablanca, Morocco, share this episode on social media, say you want to win, and you'll enter a raffle to do so. Thanks for sticking around. Now for my discussion with Harper Carroll. Harper Carroll, welcome.
Thank you for having me, Tejas.
I'm so excited for this discussion, mainly because I started paying attention to the content you've been putting out after AI Engineer World's Fair, which is organized by a dear friend of mine, Sean Wang, aka Swix. And since then, I think you created some content at this conference too. I saw some stuff with the Grok folks, among other things.
Yes. Yeah. I did a bunch of interviews there and then did like an on-the-floor video and then decided to check out one of the guides, demos that the Grok guys showed me on my own, and I made some content around that. So it was a great fair. Also love Swix.
That's so cool.
person.
Yeah, we should have him on the podcast at some point, but I'm intimidated. He's just so intelligent and always doing stuff. So we'll get him one day. I'm so with that, I'm super excited. All the work you've been doing. I've saw your course. You've created a 10 days of AI basics course, which I've tried to follow along, but admittedly struggled. Um,
Oh no, that means I'm not doing my job well enough. Which one
no,
are you watching? Instagram or
it's
YouTube?
It was YouTube. Yeah, it
Okay.
was the 30-minute thing. And I just yeah, that's probably what we'll do in the discussion today is make that accessible more so to people from the podcast. And we'll
Careful.
put links in the show notes as well. But before any of that, Harper, I'd love to just establish like a base of discussion around AI because and the reason for this is I've been thinking about this all day leading up to this because AI used to be just a concept, artificial intelligence, like mimicking intelligence. And we had neural networks to model the brain, etc., in software. But lately, I've been hearing people say things like, I've been talking to an AI. This resume was generated by an AI. And we talk about them like they're humans now. So with that, I wonder if we could just to start the discussion define what is AI from your perspective and experience.
Well, from what I was trained, like I guess classically, so to speak, because I got my undergrad, my master's at Stanford in computer science with a specialization in AI, they taught us that AI is a broad term that represents any kind of simulated computer intelligence. So, for example, if you were to hard code a computer to say hi when you say hi, so if input equals hi, return hi, that can simulate intelligence. If you happen to say hi and it says hi back, the person on the other side could be like, wow, like it's smart, but it's really not smart. That is also AI, at least that is classically defined as AI. But then machine learning is where you're actually learning from data and you have a machine that learns on its own and actually is more intelligent in that way. Like it actually has some kind of intelligence. I think more recently it seems AI now just kind of represents machine learning. It seems like they've become interchanged, but classically it's just any kind of simulated intelligence would be AI, and then machine learning is learning from data in order to behave intelligently. So in the contrary example for machine learning, rather than having it say hi whenever someone says hi, you give it thousands of transcripts of conversations, and it learns when someone says hello, how are you, hi, sup, whatever. Then it can respond from uh, an array of possible outputs that it's learned from. So it's learning from data how to behave as opposed to just being told.
Awesome. This is very interesting because I've been saying this for a long time. I've been saying, and tell me if this is true or not, but I've been telling folks that AI nowadays is very hyped. Like if you watch the Google I/O keynote, you have Sundar saying AI like 122 times, I think. And there's the memes, right? It's people just chopping the times he said AI, and then the keynote just looks like AI, 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 AI.
Yeah.
I've been telling people that AI, at least to my knowledge, and I think you're kind of sort of cementing that here, is it's it's equivalent to the logic in Pac-Man. Like when you eat the cherries and the ghosts start avoiding you, that's an example of that's intelligent behavior. It's a logic gate. Does that qualify as AI?
Well, okay, I want to answer that, but first I want to just go back, and I realized I missed something. I want to be clear that machine learning is AI. It's a subset of AI. All machine learning is AI. And so AI in that sense is actually broader than what people think. So AI, people think of AI now, like this is probably one of the most common misconceptions about AI is that people think it's just, when you talk to like a chatbot like ChatGPT or Claude or whatever, or, that's what they think AI is but it's actually there's so much more than that. It's your ranking algorithm. It's suggested posts, whatever. So we can get back to that. But then back to your question about Pac-Man. So you're saying, can you clarify? So you're saying Pac-Man is
Sure.
AI because it's a logic gate.
Well, no, I'm saying an example of AI is the logic in Pac-Man that has the ghosts that chase you change
Yeah.
their mind, so to speak. Meaning when you eat the fruit, they turn blue and they start avoiding you.
Yeah, that sounds to me like not machine learning, but it sounds like AI in the classical sense, right? Where you've programmed it to act intelligent when you eat the fruit, it no longer follows you. So that might be AI. It's a little bit, yeah, it's like it's simulated intelligence. The little things seem intelligent. I don't know, that
Yeah.
one's a tricky one, but that doesn't seem like machine learning to me. That doesn't seem like AI in the sense of what we're doing, what is broadly used today by AI.
Right. Definitely. What I'm getting at is there seems to be multiple subsets of AI, as you mentioned. Machine learning is one of them. And one of them is also just rule-based AI, right? Where like the
Okay.
programmers know ahead of time, like I'm just going to write a bunch of if statements and I'm going to
Yes.
fake intelligence. It's literally artificial fake intelligence.
Mhm.
So there's what I'm hearing from you is there's this rule-based AI, which has been around for literally centuries, if not
Yes.
decades.
Yes. Yeah.
Um, and then there's also deep learning and neural networks. Let's talk about that a little bit. How does that work? So I have there's a great YouTube channel right next to yours, which is called Three Blue One Brown that
Oh,
I've
it's my next one. I'm honored.
yeah, for sure. It literally shows in my recommendations like there's Harper Carroll and then there's Three Blue One Brown, um, and and these are like visual. There's like it's a slideshow with things, but I still don't understand it. Can we, for in a sort of surface level way for the listeners, break down machine learning and neural network style AI?
Yeah. So neural networks, and again, I have a whole video on this in my model architecture video. So it's
We'll put
day
a link in the show
19.
notes.
But neural networks are a type of machine learning. It's a way that a machine learns. It kind of models the structure of a brain. Some neuroscientists would disagree with me on that, but like broadly speaking, it has neurons and the neurons interact with each other. And um, so it's kind of modeled after a brain. So neural networks are made up of layers, neurons, which contain neurons, and activation functions. And so the structure of how like in depth do we want to go?
This is
But I
great.
guess
No,
let's
it's
start on the top level
yeah.
where these layers are made up of neurons and the information passes through. So it starts on one end. So imagine it's like kind of a body,
Hmm.
and you have like the torso and then the bottom half, and then it's like goes in and then comes out the other side. Oh, I didn't think about that, but okay. And then the input goes in, is processed through the body, and then comes out the other side. You have your output, right? And so what you're learning is from these layers, each of the layers have neurons, and what those neurons learn as the model is in its training phase, it starts off kind of at an initial state, whether that's, you know, totally knows nothing. Like it's just, so let's start with the example of a computer vision model classifying images into images of banana or images of orange. And every single input image is one of those. There's nothing outside of that. And so you could have it start off with, totally just randomly guessing, or maybe it has some, other model, some awareness of something already. Anyway, it's learning by taking in new images. It's learning how to adjust the neurons in its mind to hold different information. So, banana is shaped like this and orange is shaped like this. Orange is orange, banana is yellow. It learns these different features of the model just by seeing lots and lots and lots of examples, not from the human saying a banana is orange, a banana is yellow, an orange is orange, a banana is shaped like this. And, so the human doesn't provide the features. So the key indicators of what the item that it is receiving is, it learns it learns it on its own, kind of like a baby would learn on its own. If it saw lots of examples of bananas, it would over time learn the different features that make a banana a banana. And so these neurons capture that information. The layers are, as it goes through, these neurons are connected to each other in different layers. So here's one layer, it's made up of lots of neurons. Here's another layer, it's made of lots of neurons. They interact with each other. And then the activation functions are a little bit more complicated. We can get into that, but it allows the model to have really complex relationships between features, but we
Okay.
can get more into that. But it's
Yeah.
structured after a brain. Is that clear? Was
Awesome.
that clear?
It's definitely a start. Probably one of my favorite examples. I've never heard this before, but it's like a human body where food goes in one side and comes
I
out the
never
other.
thought that just came to me.
But here, let me tell you what I've understood. And I'm probably going to get something wrong, but I think this is very important to spend time on this because we really don't have a discussion unless people can come on this journey with us. And so what I heard is there's two layers that simulate a neural network, aka a human brain. There's the input layer and the output at the end, where the inference is made. So it's identified with some probability, some percentage probability that this is a banana or this is an orange. And the input layer is just like rough visual data. It's just an image. It's an image where you don't really know what's in there. And so in between the input and the inference or output layer, there's these things that are called neurons, which if we speak software, is that just a matrix? Is it just a big array of numbers? Okay, so I'm getting that. Fantastic.
Yes,
And so
numbers that are tweaked as the model learns.
And these numbers are do they represent how likely it is to be something? What do the numbers represent?
The numbers represent so ultimately what machine learning algorithms are is just an equation modeled
I love it.
as, these layers or whatever, but ultimately it's just an equation.
It's just math.
Math. Yeah, exactly. And so what you're doing is you're tweaking the kind of like the constants. Your input is the variable and you're tweaking the constants it's a super high dimensional variable. It has, however many 100 dimensions or 100 by 3, whatever. And then you're tweaking the constants that go along with those variables and then how they relate to each other. And then as it goes through the system, it's basically you're forming this mathematical equation that ultimately stays static. So after the training phase, that mathematical equation represented by the neurons and, the activation functions stays static. And then you just apply that equation to every input that comes in.
Awesome. This is so great.
Yeah.
I love it. So part of the reason I do this podcast is, it's in the intro, eliminating imposter syndrome. And Harper, there are so many people who have just serious imposter syndrome about this stuff because they didn't study it for 10 years at Stanford like you did. And they just don't get it. And worse than that, a lot of us are just afraid to admit that we don't get it, especially because we're working in jobs where it's sort of like expected that you know this. And so the work we're doing here together is so, so valuable.
So I have an interesting story about it. I was at Meta. I was working at Meta for about 4 years. I was just I was on newsfeed ranking as an intern, and then I came back and worked on civic integrity, and then that ended up being global integrity. So just protecting the platform, various things. We can get into that if you want. But I was working with this stellar AI engineer. He was a celebrity. His output was insane. This was back in 2019. Early 2020. But he was the famous AI guy. He was working from New Zealand before being remote at Meta or anywhere really was a thing because he was that good. He wanted to move there and they were like, okay, fine, just stay with the company. And so he was that good. And so I went and flew out to him to work with him for a project, an important project. It was just me and my co-engineer. And he told me, we got to be pretty close, and he told me one day, Harper, I have imposter syndrome every day. Every single day, I'm you're not good enough, you're not doing enough, you don't know how to do this, you're not, he had imposter syndrome, and I looked at him, I was like, you are a celebrity, you are an God knows, I8, I9, super high up in the ladder and outperforming crazy, a celebrity for a reason. And this guy still feels that he has imposter syndrome. And so
wild.
I was like, it's never going to go away. And I think if you just acknowledge that never goes away. And, some people, I shared this story on my Instagram and some people were like, yeah, it goes away eventually. I think in some cases, you start to feel confident in what you're learning. You feel but I think you should always be pushing yourself into new areas. I mean, maybe you don't need to, but what I like to do is to always grow and expand and push myself. And so I've gotten better at quieting that voice. I really have. But I just want people to know that it don't expect it to ever go away. Know that even the best people at the best companies doing the most work that works, even they have imposter syndrome. So just, and then eventually, maybe if you know that, maybe that voice can go away. So, but it's also good. I mean, it's a driver too. Like, just keep learning, right? Like,
Yeah.
if you can let it be a positive thing too, like, oh, I need to like research this. I need to get better at this. I need to do that. But just don't let it like cripple you. And also,
Yeah.
don't be afraid to be a beginner and to look silly and ask questions. I think one thing that I've always been good at is not being afraid to ask questions. Like, I was the girl in the advanced math class who would just ask, 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 ask. And no one else would ask. It was always me. But then everyone else had the same questions. Just no one wanted to admit that they had the question. And so I helped everyone else learn, including myself. And just like, don't be afraid to look dumb, because ultimately, by not being afraid to look dumb, you actually like, I found you don't look dumb.
Yeah.
And everyone knows what it's like to be a beginner too. And I find too that the people who pretend to know more than they do, like, you can see right through it. And often the people who are really good at what they do know that they don't know everything, and they're willing to be like, oh, I don't know about that. Tell me about that. Like, anyway, I'm rambling, but it's an important story about imposter syndrome. And
Yeah.
yeah.
That's so good. I also knew a celebrity developer at Meta. His name is Dan Abramov, and he would cringe that I call him this, but he just is. You know, he built React front end framework. He was part of the team, and
Yeah.
he just absolute brain. His description on Twitter was his bio said junior developer for life. You
Oh,
know, yeah, I think like part of at least what I've learned to get rid of imposter syndrome, I have it also. I have it as a podcast. I have it as everything I do. And the thing that helps me overcome it is to just say, yeah, I'm totally an imposter in some ways,
yeah.
and that's okay, you know. And I'm so glad we're making some headway here. Okay, so it's a list of numbers, and activation functions. What do the so I was taught, and this is probably wrong. I'm so glad to have an expert here. I was taught that these numbers are representative of. So it's just trying to find a path between an input picture that it's never seen before,
Yep.
and the expected output. And so the training process is you get a bunch of inputs and outputs, right? And so you have this picture equals banana, that picture equals orange. This picture, so you've got inputs, and I think they're called labels. I took a class once.
Yeah. Yeah. Yeah.
Okay,
Oh,
so outputs are called labels, great. And so you showed the machine this equals banana, that equals orange, and the training function is basically trying to get to the correct answer with the least friction, so to speak. And these numbers in the layers in between the input and output are finely tuned such that it arrives at the correct answer with the least friction or resistance.
I
Is
wouldn't
that accurate?
say a resistance. I would say with the highest probability. So as you got right, you, in the end, it has a probability of, in this two class system, two classes are banana and orange, it has a
Nice.
probability of each, and it chooses the higher one. Typically in this kind of classification system, you just grab the highest probability and that's your output. But before that output, you actually do have like a class probability that you could look at. You could go back and look at that. You want a super high probability for
Mm,
that's the further away you are from, so say it's like 51%, 49, your loss is going to be high. So you want to reduce the loss. The loss is the difference between the correct answer and what you guessed it to be. I guess in that case, like, if you're, it depends on how you're calculating the loss, but you want it to just know that it's a banana.
yeah, I
Yeah.
got you. So someone ELI5'd this to me once, and now it's coming to memory since we're talking about it. And they said it's like, so you start a walk. You start a walk on a hiking trail. That's your input layer. And then you walk forward, and you already know your destination, but
Yeah.
you don't know how to get there. So you walk forward, and this is like the first layer of neurons, and you go left, and then you go right, and then you go right. You make a series of turns, and eventually you do get to your destination, but then you look back, and you're like, oh, I could have taken these other turns that would have got me here faster. And I believe they call this backpropagation. Look, I'm so like, this is very unstructured knowledge that I'm just sort of recalling here. But there's the training process. They explained it to me as you just take a bunch of turns, you get to the destination with some probability, and if it's right, then you do it all again, but this time try and make fewer wrong turns until you make almost no wrong turns and you get to your destination with the highest probability of a right answer. Am I just saying things that don't make sense here, or is there some truth to that?
So I never thought about it in the case of like making wrong turns, because it's going to do the same amount of processes. It's not going to like go in the case of a neural network, it has the same amount of multiplications every time. It's not going to like, you know, do more if it's not
Right.
sure. It's just going to have its output. Like if it
Right.
does 10 equations, it's going to do that every time. So I think of it less like that and more of it gets better at identifying features that truly matter. So like, perhaps in some you see in your data set that your training data set. So you have your training data set, you have your validation data set, which is like a kind of a testing data set as you're training, so you can see how the training is doing. So you don't train on the test data set, it's like withheld. It hasn't seen it, makes a guess, but you're able to like see its performance. If you happen to have in your training data set that it just happens to be that every picture of a orange has a red dot in the background, it is going to, and then in the test data set, it, let's use the example where the red dot is in the bananas background. In the validation data set, it has a picture of a banana with a red dot in it. It might like make a mistake or think that that is actually a feature for a banana, for an orange, but it's not. And then it gets confused. As it's learning, it's going to kind of see more and more and more examples, and it's going to see like, oh, that dot actually isn't a feature for an orange. That's just a coincidence. So I can prune that. And that's how I see it, as opposed to like, so I guess like it's taking wrong turns in the sense that it might be seeing a feature that doesn't actually,
Yeah.
but it's not actually like taking longer to get there. It's just performing not as well. Like it's just
Yeah.
guessing worse, but it's
Yeah.
not like guessing as well, but it's taking longer to process.
Yeah, no, I love that because it's so I love how close this comes to actual human workings. Because for me, I like when I look at something, this experiment with the gorilla, where there's like a basketball video and there's a gorilla dude that walks in the background.
Yeah.
Like this is exactly what the machine learning model is doing in the training process. It's just not noticing things and focusing on the features that matter. Awesome. That's super interesting. And I do appreciate that we're going pretty deep on machine learning here, which some say is very different than AI engineering. And I do want to get your thoughts on that. But before we do, one last question about the process with
Yes.
machine learning
Yeah.
is what are hidden layers? And why is this? I've taken a course once on TensorFlow, and they just said have 4 hidden layers. And I get very scared around like numbers that are just told to me. I want to know why, like, how does one determine how many hidden layers you need, and what happens if you have too few or too many?
Great question. So hidden layers are the layers that have the neurons in them. So they're the layers that contain the, constants that we're tweaking, variables that end up being constants in the equation. So, but as we're training, they're variables, right? Because they're changing. But they're the neurons. The input layer is not neurons. It is the X. It is the input layer is your input. So in our case of the banana orange classifier, it would be the image of the banana flattened. So right, images are actually just, if it's a color image, it's a 3-channel RGB. So it's like 3 different stacked matrices where the matrix, is the image, right? And different values for red, different
Red,
values
green,
for
and blue.
green, different values for right. That's how it's represented. That would be the X. That would be the input layer. The hidden layers are the ones that we're training when we're training the neural network. And then the output layer is like, the transformation that's done at the very final hidden layer. And then you get your output, your, highest probability. That's your answer. that you provide, whether it's right or wrong, that's the one that's output by the model. So the hidden layers, again, those are the values that contains the values that we're tweaking, plus a bias term, but we can get into that another time. It's like, no, but it contains the values that we're tweaking. If you have more hidden layers, you have more specialized neurons. So imagine, so when you have, you could have the layers be very long and have many neurons, right? So you could have the very tall layers and therefore have a lot of neurons, or you could have many layers and have a lot of different multiplications. And so those are two ways to have a lot of neurons. If you have more hidden layers, that implies that you have more neurons, and having more neurons and more connections between neurons, right? So whereas if you just have them be really long, I guess you have more connections too, but it's different. It's not like compounded, right? If you have more neurons, you can capture more complex relationships between things. So you might have heard of models that are like 7 billion parameters versus, 130 billion
Yeah.
parameters. So that's how many neurons that they have at a basic level. And so when you have more, you're able to capture more complex nuances. So for language, it's really helpful to they find that having so many different layers, so many different neurons, they find that having those extra neurons is really useful because in language and kind of the way the brain works by connecting concepts, and they find that that's really useful. Whereas in something like a computer vision model, you tend to need fewer neurons to do well. But yeah, so the hidden layers they contain neurons, and more hidden layers implies more complex functionality. However, you need more compute and you need more training data in order to really properly kind of capture all those nuanced relationships.
Awesome. Thank you. Is it a safe assumption that you'd need to scale your level of hidden layers with the complexity of your input layer? Meaning if it's a black and white image, I probably need fewer hidden layers than if it was a full color RGB matrix.
Yes. Yeah, right. As the data gets more complex, you would need, and as there are more complex relationships between variables. So let me just give this example in terms of, as we're talking about relationships between variables. We talked about the activation functions. So I mentioned that it allows for complex relationships between variables. What that means is it allows for nonlinear relationships between variables. So let's look at an example of a linear relationship between variables. Say you're looking at houses in a certain region, so like the same zip code, okay? You would expect that basically every house, the larger it is, the more it costs. It's like basically square footage is directly related to price. And so if you're modeling that, you don't need, it's just a linear relationship. They're just directly related.
Yeah.
But if as you expand and there's more variables of, where it is and there's just all these more variables as you expand your region from just this one zip code, it's nonlinear. And so if you were to graph the houses in the one zip code, it would be up and to the right, right? This square footage, this price, this square footage, this price, this square footage, this price, and it goes up and up. But if you were to expand it past that, you might see just kind of all over the map. And so if you would want to actually capture that relationship, you need a nonlinearity. The line to capture those data points is nonlinear, which implies there's more complex relationships between the two features.
Fantastic. That's thank you. That's really solidified my understanding of hidden layers in the context of things. Do I then understand correctly that all deep learning models ultimately build on this model, meaning input, hidden layers, output. Because like there's specialized architectures. You also talk about this in your 10 Days of AI Basics course. There's, for example, recurrent neural networks and long short-term memory. And I guess there's the transformers architecture behind the GPT models.
Yes.
Do those fundamentally use these same primitives that you were talking about? And if so, how do they build on them?
Yes. So deep learning models indicate that you're using a neural network. So when you hear the term deep learning, that means a neural network is being used for the learning. And the ways that they are different for different applications, or the ways that you can kind of build your own model, is you can have your own choice of hidden layers, like what type of hidden layers. So you talked about, LSTMs, RNNs, CNNs. Those are all different types of hidden layers that are used for different things. So for example, CNNs tend to be used for computer vision. They're good at like they slide little boxes through the input data and are able to kind of like, they're really good for like detecting objects and images, right? And so there are different types of hidden layers that you can use. There's different activation functions you can use. So they're nonlinear equations that allow for this nonlinear function to be created as opposed to just the linear one. So it allows for these complex relationships. And then like the number of layers that you use, the number of neurons that you use, these are all ways that you like mix and match to create your own neural network, your own deep learning model.
That's so interesting. Okay, so these architectures are they're like one level under the traditional deep learning model, so to speak, where it's inputs and hidden layers and outputs, but the hidden layers have different specializations, as you mentioned. That's
Yeah.
so cool. That's what I was wondering about, because there's this paper, right? The paper behind GPT, the transformer architecture, called Attention Was All You Need, and they model in it attention, multi-headed attention,
Mhm.
which I think as a concept is cool. I just didn't know how it fit into the whole picture, so to speak. And now you've answered that.
Yeah, right. It's like the special hidden layer that they
Yeah,
use.
excellent. Great. Thank you so much. Final question about machine learning, and then I want to switch to AI and explore really the relationship between them. Embeddings. Do embeddings models also just use a neural network like this? And how do I guess the really basic question I want to ask is, how do they actually work? I would assume that if you want to generate embeddings from text, for example, you'd have a model that is very familiar with natural language, and then through the hidden layers arrives at just a vector of numbers. But like, the question I have is, how does it capture semantic meaning? How does it know? How does it learn that, like hot dog and pizza belong in the same sort of high dimensional space, and airplanes are somewhere else?
Yeah. Oh my gosh. Okay. I actually haven't done, this is a great one for me to do an explainer video on. I haven't,
Yes.
so because this is going to take me some time to like explain it in a basic way, but like,
Sorry.
no, it's just been a while since I've thought about this. So it is what embeddings models do is like it creates a numerical representation that captures the semantic meaning of a word. So for if we're talking about words in this case, embeddings for words, you might have heard of like word to vec, where you
Yep.
pass a word and then you get a vector that represents that word, and then you can use that for your models. Because again, models need to take in inputs that are numerical. So they're not just like reading the string that you pass in and working with that. They need to actually have a numerical representation of the word. So when you talk to, ChatGPT, your word is being transformed into a token. So there's a dictionary that says like, what integer is this in this, 10,000 words in my vocabulary? Which one is this? So maybe it's number 5. Maybe it's number 9,999. And then that is mapped to an embedding. And so what happens when you're training these embeddings is that you are like learning, given many examples of essays and words that go together, you're able to over time capture these semantic relationships between the words. I'm struggling to give a really clear explanation of this,
That's
and I'm
okay.
sorry. But I need to this is something that I have to sit down and actually like
Sure.
think how I'm gonna explain. Um, but my apologies. This is a good one to
No,
make a
that's
video on. This
yeah. Yeah, and we'll put whenever that video is out, we'll put a link to the show notes, and we'll retweet it and whatever social media to heck and back. Awesome. Let's switch and talk about AI. And the reason I want to talk about this, especially with you, who you know your credentials are bananas. AI bachelor's and master's from Stanford. Jesus. I
there are
there's
people with far more credential than me, but thank you. I appreciate the kind words. It was
there's a
a lot of work.
I can imagine 10 years. The the question I wanted to ask is, so I just professionally I speak to a bunch of people. I mean, yeah, on the podcast, okay, but also at conferences. I'm literally going to New York next week, and there's just lots of travel, and it's usually at AI conferences where I found your work, and it's usually people who attend them to learn. And so I can't emphasize enough how important the work again we're doing here together, but you're doing on YouTube is because people just there's a conflation now between machine learning and AI. And so I've gone to a bunch of folks at these events and I've asked them like, hey, do you think you could be an AI engineer? And the answer is usually an overwhelming no. I don't think I fit. I don't think there's room at this table. I just can't do it. And I say, why? And they say, well, because I didn't go to school for it, literally, which is, again, why I'm so happy you're here as someone who did go to school for it. But look, I don't understand linear algebra. I don't get matrix manipulation. Like all of this is way above my pay grade. I'm just happy being a front end engineer. This is honestly what most people tell me. And so I then point them to Swix's article on latent space, where he outlines this role of the AI engineer
Yeah.
and makes the claim that it has nothing to do with machine learning. Like you'll never. I think Karpathy even said you'll never have to train anything.
No.
You just talk to an LLM, get a
Yeah.
response, and solve a problem. Does that track with your training? And how do you see AI and its interplay with machine learning?
Totally. Well, my training was in deep learning, but as these where you would kind of build your own model. But as these models are coming out that you can just query with an API, I mean, engineers have been working with APIs forever, right? I wonder what percentage of them that you talk to have worked with an API, probably like all of them. So
Exactly.
you're just using an API and you just send it input and you get your output. And then you can just tweak the input that you work with. You don't have to train the model. You don't have to understand how it's working under the hood. You don't need to know any of that. And yeah, Swix was right in that. And you don't have to have this classical training. You're just kind of playing with a chatbot in the sense of if you're working with a large language model, for example, or maybe you're doing image, or and as you don't the way I see it, I've heard in the scene that people are like, oh, that's a rapper company. Like it's kind of scoffing at rapper companies. Have you heard this?
Yeah, that's so common.
Um, the what I tell people is that's fine. In fact, if you can really make first off, if you can really make an application that is really good, that is super easy to use, I mean, I work, right? I teach AI broadly on a broad scale. Most people don't even know. I just did a poll the other day and asked my followers, how many of you know how to make an AI image? And 50% didn't. And I was like,
Wow.
wow, I'm not doing my job well enough. Well, I teach like, machine learning concepts, but I need to do more more kind of hands-on things because on Canva, it's built right in. You just type what you want to see, and then Canva
Right.
makes it free too. It's like life hack. Canva has free image generation right now. So if you want a free image, there aren't that many people who offer free image generation because it's expensive to do it, to generate an image. But um, so what I'm trying to get at is that there are so many people who need to use AI for their purposes who they're not going to code. They're not going to they just want to be able to go to a UI like they're used to and have AI kind of integrated into that. So if you can build a really strong wrapper company, that's actually really smart because I'm sorry, you're not going to compete with OpenAI, with Anthropic, you're not going to have any kind of model with secret sauce that beats them. I'm sorry, you're not. And also, well, if you're working with like large language models that need a lot of variables, I mean, maybe you have like a small personalized machine learning model for ranking or whatever, that's yours, that's different. I'm talking about large language models, image generation models. You're not going to compete with the big guys. And so if you can just build a really seamless, amazing UI with, API calls, whether that's, an agentic workflow where you work with a large language model and then you parse it and then you do something else. I recently met a guy who's doing like, phishing detection, like preventing attacks on companies. It's an agent company where if you get a phishing email, then it like launches this whole thing. So it's an agent company because it's a large language model. Then it also like takes actions on the user's behalf. If you can make that really seamless for someone who isn't a coder, you are so far ahead because then you can just swap out the API and those are what's going to do well. And so I hear people saying like, oh, like they don't have a secret sauce. It's a wrapper company. That's fine. Like I really believe that's fine. So just learn how to build a system. So the AI engineer, right, what they do is they are software engineers. So if you are a software engineer, you can be an AI engineer that integrates AI into what they're making via an API. You can make so much money with that. So do it and don't worry about the haters.
Yeah. Don't worry, they hate us because they hate us. I saw Anthropic. I saw a job posting on Anthropic's job board. I think it was yesterday, where the annual salary was listed as like $405,000 a year. Yeah, I know, right? And so people can. I so appreciate you saying that, Harper. People can actually make that by maybe at Anthropic you're going to be training models, but for AI engineers typically, you've just got to be really good at querying an API. And I love your take on wrapper companies because I've built products before, and it's super hard. Like it's easy to get to 80% done, but that final 20%, even if you're not doing complex machine learning, it's just impossible to get the I's dotted and the T's crossed. And so
for like a UI, like building a UI around. Yes, no, it is. People, I remember I was talking to someone, they were pitching a product and the investors they were pitching to were like, what's your secret sauce of the model? Like, they had built this elaborate UI agent system, whatever. And they're like, we built that in a hackathon. I'm like, no, you didn't. You built something really basic, like you had the idea, but to actually make it work seamlessly that takes a lot of time. So yeah, anyway, you get it.
Yeah, and almost nobody does it right. So what I'm hearing is the takeaway is to get really good at finishing the work, and not maybe get bogged down in the details. You mentioned something interesting. You mentioned about this secret sauce, and you mentioned that if somebody here listening wants to build something with AI, you said you're never going to have a model that beats OpenAI or Anthropic or Mistral or these big companies because right, good. Yeah, a large language model because it's just the compute and the resources you need are not an individual person's level of attainable, as far as I know, unless you're like Bezos or Musk or something. But that said, I wanted to get your take on smaller specialized models, specifically in the context of things like Apple Intelligence, where they've got a tiny model that runs on every iPhone, that it's a language model and it seems capable. It hasn't shipped yet. I don't know when it's going to ship in Europe. But do you think that may be the future? Instead of like, so we'll lean on companies like OpenAI and Anthropic, et cetera, for large language models. But do you think there will be more of an emergence of smaller language models that are specified to people's tasks? And this is what might end up becoming businesses over time?
Yeah, I do. I used to really believe this, that people would like fine-tune models for their specific needs. They would take a small model and make it like super specialized for their tasks. I think I could see that being common. The thing that has given me pause is that I think in a lot of there's benefits to that, right? Because then you own the model and it's yours, it's specialized, whatever. You don't have to like pay Google or Anthropic or OpenAI like indefinitely forever. You have your own model. But what's given me pause for that is um, as context links get longer, as these like information retrieval systems get better and easier to use, like, so people know about the concept of hallucination, right? So, and if you don't, it is when, because large language models are just like, statistical probability machines, um, they can make things up. They can like just think that, they can just hallucinate. They can decide that the probability of this word is, slightly higher than the other, and then it inputs something wrong, and then that's wrong, and the next token is based on the prior wrong one, and it just like goes down this path where it's just like making things up. And there are lots of reasons why that happens, and I can go into that if you want. But anyway, this is a problem. And one thing that helps with that is like these information retrieval systems where it is like actually looking at concrete data and pulling from it. As that gets better, as context lengths get longer, as in the context is the information that you can fit into the model's working memory, kind of like its RAM, like it has access to that. There are some caveats where, as if the context lengths are really long, information at the beginning, so like really far away from the most recent information, is like can be dropped, whatever. There's like, again, these are like caveats that need to be considered, but ultimately, as context lengths get longer, as it can fit more information in its brain, working memory, the need to fine-tune might become less and less important. Like you could just like fit a manual in there. And then you have this like broadly working system that, again, like OpenAI's is going to be a lot smarter. It's going to function a lot more like a human brain than a smaller model. So if it is more like a human brain and it has this like book of information
Right.
and access, that still might perform better than like one of these small models that are, fine-tuned on your data, but the brain isn't as smart. Does that make sense?
That makes total sense. My fun fact, I've been doing this podcast now for almost a year, and can you imagine? So actually twice a week, 2 hours ish. That's a ton of content, and a lot of folks
Yeah.
they feel the need to come up to me at events and go like, "Hey, I don't have time to listen to it. Can you do shorter content?" And I said, "No, that isn't really the model." But I on the website, on my website, there's a search powered by an LLM that you could just ask a question like, what are the hidden layers whenever this is published, and it will just point you not just to this episode, but to the point in time where you explain hidden layers, and you click on the timestamp, and it just like starts playing. It's kind of bananas. The reason
That's so cool that you have that for your own
yeah,
podcast. It's so rad.
yeah, it was fun to build, and it's using some of these retrieval mechanisms which I want to talk about. But the point I wanted to make was it became very expensive very fast, just because people be searching for things all the time, and there was some semantic caching, but still doing an inference with. So we were using 4.0 in the beginning,
Yeah.
GPT 4.0. Actually, it wasn't even 4.0; it was just 4, and it was my OpenAI build was painful. And so you mentioned fine tuning. I ended up then switching to a custom fine tune of Mistral 7B based on everyone's searches and responses. And the price differential, Harper, was absolutely bananas. Like it was I think 70% cheaper than before.
Did it work as
And
well?
so that's a really great question. It does work. It doesn't work as well as GPT-4, but it works good enough. Meaning,
Work like,
I actually
does
say
it
say
work
again.
30% as well?
It work. That's a good question. It definitely works more than 30% as well.
Okay.
I'd say like maybe one in every 10. Actually, not even that. One in every like 20 to 30 responses is bad. And the way I know that is when we serve an answer, it's A/B tested. So like you may get a response from the fine tune, or you may get a response from OpenAI, depending on my bill and how much debt I've accumulated.
Oh,
And
smart. So you
Exactly. And
okay.
what's that?
So you've kind of you've blended.
Exactly. Exactly right. And so some people, and I can obviously everything's logged. So when people sort of abandon the site early because they didn't get their answer, then I
Yeah.
can go in and look at which model said that, and then it like either improve my fine tune or do something else.
So
But
you
it's
actually
very
tuned, did you fine tune and use RAG on your own personal model?
yes.
Okay. Okay. I was going to say just a fine tuned model. I can't imagine did that well.
Exactly. So it's the RAG was used for also the training data. So the prompts have here's some context and give me the answer.
Yeah.
And so there's RAG and fine tuning, which is exactly what I wanted to come to in our discussion. I'm so glad we just naturally came here, which is there's this discourse right around RAG versus fine tuning, and I've been telling folks for a long time that they're not antithetical to each other. They're complementary. Like you almost always want to RAG and fine tune because of like correct me if I'm wrong, Harper, but I see LLMs as hallucination machines. They're sort of supposed to hallucinate by design. I believe in the architecture, there's a non-linearity feed forward layer that introduces the potential for hallucinations. By design, you want the novel outcomes. And so even with the perfectly trained model, it will still hallucinate because it's a feature, not a bug. Therefore, you need RAG and they're complementary. Do you agree with that?
Mm. There are ways to tweak, like having, there are, have you heard of temperature?
Yeah, that's the how creative or rigid the generation is, right?
Yes, exactly. So like if you have a higher temperature, it's going to spread the probability of the next token more broadly across all the possible tokens, as opposed to like have a super high probability for the one that is likely to be the next one, and then just choose that one. So if you increase your temperature, you increase hallucination likelihood.
Mm.
And if you decrease your temperature, you decrease it. But again, there's always that probability of it being wrong or making things up. Um, and so uh, I lost my train of thought. Oh,
Are you
hallucination
hallucinating right now?
versus literally. So large language models versus RAG. Yeah, they are complementary. You want to fine tune on the kind of the style of behavior. So like the style of the task is what you would fine tune on. And then RAG can help you access the information, kind of like, yeah, like have your data of like your book that you're actually going to access.
Nice.
So like if you
Yeah.
think of it in like uh, a journal, um, you could fine tune it so that it uh, talks like you. Because I have a big guide that's like how to fine tune on your journal. That was like one of my
Oh,
first
awesome.
things because I got into education via fine tuning guides. I don't know if you know this.
I
Um,
didn't know that. Wow.
yeah, I tangent here, but I was at a startup that made developing on GPUs really easy to use and like just made it really easy to like get into it into those development environments. Get a GPU from across like AWS, GCP, whatever. And they needed people to actually use it, but no one really needed to access a GPU on their own, except unless you
Mm.
wanted to fine tune a model, but no one really knew how to do that. And so I made a guide on how to fine tune Mistral 7B I did it on my journal entries, but you could do it on your own data. And I think it has like 60,000 plus views on
That's
YouTube
awesome.
now, but it blew up. So I had like when I first started Twitter, I had like 40 followers on Twitter, and I posted this guide on how to fine tune Mistral right when it came out. This was about a year ago now, probably like almost exactly. And I can't believe it's only been a year. And it blew up. It got like 50,000 views, and it was
Wow.
crazy. So there was this like really strong need. And then I made the guide on how to fine tune it. I did it in a Jupyter notebook. So all the code was there for you. You basically had to do nothing except kind of insert your data. And I made a video walking through the guide, teaching people, about QLoRa and like, how to make the model smaller by using QLoRa and things like that. Um, and yeah, it blew up. I was getting millions of views. I have people come up to me at conferences like, "You're the girl who taught me how to fine tune a model. Like, thank you. Like, like we use that model now in my company and all that." So that was like that was my thing. I was like the fine tuning person.
The
Um,
fine-tuning person.
that's how I got started. But yeah, my first guide was fine tune on my journal entries. So by fine tuning on my journal entries, I had the model talk like me. I had it, um, yeah, it output journal entries in my style. And then if I had RAG, then it could have like, referenced specific events from my life. And, if you're fine tuning it enough, if you tweak the parameters enough, it might reference specific events from your life, but you can have it do that with less risk of it hallucinating when you use RAG.
Awesome. That's so cool. So fine tune for style, and then RAG for accuracy and up to date information is what I'm
Yeah.
hearing. I think I need to apologize to the listeners because we sort of just started dropping the term RAG without defining it.
Oh yeah.
Yeah,
Retrieval
for folks,
generation.
amen. Retrieval augmented generation. Can you tell us, like in 2 sentences, what it is and how it ties into prompt engineering, maybe?
Yeah, so it takes what you're asking for and finds and has this like embedding of it, right? And then it looks at the data that you've given it, whether, it's your like list of facts about your company, and it has embeddings of that. So again, these are these numerical representations. And you had mentioned this before, how like king and queen can be near each other in an embedding representation, or like king as to queen is, relevant to woman as to man, or man as to woman. And embeddings put a word on a super high dimensional space. And if you imagine it in like a 3D space, words that are similar go together. And you can kind of like
Yeah.
add and subtract words. So like king minus queen equals man minus woman. Like it's really interesting. And so anyway, you have this embedding of the prompt of yeah, what you've sent to the model. Then you have and like what you'd like to retrieve, and then you have the embeddings of the information, and it's able to find, given these embeddings, like how close are the embeddings, and it'll retrieve the one that it sees is closest to the question that you've asked it.
Fantastic. I've explained RAG to folks. I love that, by the way, what you said, this thing about what was it? King minus queen equals man minus woman.
Yeah.
That was so cool. Like putting the math background to it. I've never done that when I talk about RAG, but it's so cool to see how the numbers are sort of inferred. I've described RAG as like being, is it exactly what it sounds like? As in, you retrieve data somewhere and you from somewhere and you use it to augment the generated output, usually through a prompt,
Yes.
where you just get like here you literally retrieve, here's today's weather. Now ChatGPT should have taken an umbrella, and that's how it is. Is this accurate? That's how it ties into prompt engineering. Meaning, I engineer a prompt with retrieved data from some real-time empirical source, and then I just give it to a model, thereby augmenting its output.
Sorry, can you repeat that one more time? You one more time?
I retrieve data and then I place it in a textual prompt. So if, for example, if I go without RAG and say like, hey, can you convert $100 to Japanese yen? Then the LLM will probably be like, no, I don't have today's exchange rate. But if I then with RAG get the exchange rate and put it in my prompt, in my text string, like here's the exchange rates for today. Now, can you convert $100 to yen? Then it will do it because I retrieved the data and I put it in a prompt, which changed the generated output. It augmented the output.
Yeah, that works.
Good. I'm so glad to be fact checked here by an expert. This is the whole, like most podcast episodes are me with people who are way more qualified than me asking questions, and I must say the failure rate is satisfactory. Great. Okay, so we talked about RAG and fine tuning. And established that they are complementary. You also, I love that you had this course on fine-tuning 7B. I wish I knew about that when I tried for the first time. It was definitely not pleasant. I failed at the eval step because they don't tell you that after training, you've got this huge set of weights, this GGLF or this GGUF file,
Yeah. Mm-hmm.
and then you do inference on it, and you've got to evaluate its output. And every time I got to the eval step, I was like, oh, it's not actually doing what I wanted. Dang it.
What you weren't evaluating it like in the validation step?
I actually don't know. You mentioned, this is what I wanted to double click on that you mentioned earlier. You've got training data, which you show the model, and the model sees and learns from. And then you've got test data. And you mentioned using the test data during training.
Yeah.
How do you do that?
Yeah. So you're not using it during training. There's 3 different groups of data. There's training, there's validation, and there's test. There's different ways that you can split it up, but let's just say that, you split it so that you have like your training data. Training data makes up 70% of the data. Then you separate 20% of the data for validation data, and then you separate 10% for your test data. When I was training a model on my journal, I actually didn't use test data because
Interesting.
I didn't really care how it did. Like, right, I wanted as much data as I could have to train the model so that it would talk like me. And I didn't really need to like test its performance on talking like me. I could just output it and be like, "Yep, sounds like me," you know? And so I decided to use that data, add that to the training data instead. But what validation data does is when you're training a model, you have these pauses, you do a series of steps, updates to the model's parameters, and then at a certain checkpoint, you determine how often you want to check the performance of the model. You use the validation data and you, again, test the performance of the model by, rather than updating the model's parameters on that group of data, you just see how it's doing. So let me give an example. Say, let's just ignore the test data for now. You decide to, you were training the banana orange model. And, we show it, 100 images, and it updates its parameters. Let's just have it update its parameters after every image. That's a choice that the engineer could make. And then after every 100 images and 100 updates of the model's parameters, we want to see how is the model doing. And so then we'll run our test examples through it, our validation examples through it, and like all of them, and see how did the model do on those validation examples. So the test examples during training equals the validation examples. We say, how did the model do? And then it gets like a percentage. And while it's looking at those, it's not updating its parameters. And so then we could say like, oh, okay, so after 100 steps, the model is 70% accurate on the validation data set. Now let's just do another 100 steps. Maybe there's new data. Maybe it uses the same as before, depending on how much you have. Again, these are all decisions that you make. And then let's test it again. Oh, look, it's going up. It's got 74% accuracy on the validation data. Okay, let's do it again. And so you hope to see this increase in performance on the validation data. There's also like a trade-off between you are seeing how it's doing on the training data, right? But since it's learning from that, there's also something called overfitting, which we can get into, where you compare the training and the validation data performance. So it is evaluating its performance on the training data, but you need this withheld set that it's never seen before to ensure that it's actually like going to generalize past the training environment, past the training data. Because you could just if you just had the training examples, then you wouldn't know if it's just learning too much, the red dot in the background for the for the
Yeah.
oranges in the training data, you won't know that that's a problem unless you bring in new data that doesn't have that red dot that's like that it hasn't seen before.
Does all of this happen though as one continuous process? Because the main question I have is if it's not updating its parameters, aka weights, when you're running the test data, then at that point is training effectively over, and have you switched over to like, I don't know, test mode, or is all of this considered part of the training process? And does that continuously like run in a loop?
Validation is during the training process. You're just pausing those updates. Yeah, you're pausing those updates of the parameters during the validation test.
Nice. Okay, so you don't have like a finished model and then you test it. You just pause training, test it,
Right,
come
you
back.
pause backpropagation. Ingredients.
Fantastic.
Yeah.
Can we define those? Can we quickly just define those terms in like a few sentences for folks?
Yeah, so that is backpropagation is how the model updates its parameters. So it takes in the input data, it makes a guess, it goes through the whole system, the current parameters of the model. This is during training. You do backpropagation. You don't do it during the testing phase or during inference, which is like when it's done training. So the data is passed through one way. I don't know if this is going to be flipped, but it passes through the model, left to right or whatever. And then it gets to the end, there's an output. And then the model says, how did I do on that? What direction do I need to step? It has a loss function. I don't want to get too complicated or too massive.
Sure.
But so then actually I'll stop myself. But it says, how do I need to update my parameters a little bit so that I'm taking a step in the direction of the optimal performance of the model? So like, how do I make myself better just by taking a tiny step towards the direction I think is going to make me better? And that causes a delta, a change in many parameters. It causes, these, right, it's highly dimensional, so it causes a change in the parameters, a little delta. So then it sends that information back, and the model's parameters are changed. So backpropagation causes this change in the model based on the performance at the end. So it goes one way through, it learns how to update its models parameters, and then it sends it back. And so that's why training is really intensive, because it's twice.
Interesting.
Like more calculations in the loss.
Fantastic. So it's just multiple iterations, getting better and better over time.
Yes, it updates it. That's how the model backpropagation is how the model updates its parameters based on its performance on a piece of training data.
Fantastic. Great. Okay. Thanks so much. Yeah, so good.
Sorry, caveat.
Fantastic.
That's an engineering decision again.
Good. Okay, let's talk about agents. You use this term, and you mentioned you met a guy with a project that's what was the project again? You mentioned it. You did mention it was agentic, and it can take actions on a user's behalf. Is this your working definition for the term? I've seen this term everywhere, and a lot of people use it differently to mean different things. I was once in a talk where somebody said they built an agent, and what they had built was, ChatGPT or OpenAI has this feature on ChatGPT where you can have custom GPTs, like you upload a bunch of knowledge and then it performs RAG on that. That's what they meant by agent. It couldn't like do stuff for people. I'm curious if we could speak a little bit about agents, what they are, according to you and your experience, and where we might see them in the wild and how we might create some.
I describe agents to people as models with side effects. So they are able to take actions or, not just like given an input, return an output. They're actually able to like navigate the world and do things on their own. So usually that involves like, if you send, so in the case of a lot of agents that are being developed today, you would say like, you would send the model, you would say, book me a flight. And then the model would analyze what you said. Maybe you said, hi, my name is Harper Carroll. I'm a member of the gold standard, whatever. Please book me a flight for this day and that day. And then the model would parse what you said into a format that works for the API. And so then the API, it would then take an action on your behalf. So it's like, or, maybe it's a like it can do many things. It can book flights, it can call, make an appointment, it can do whatever. So it works with the large language model. It's like, but it also can take actions on your behalf in that case.
Great.
Yeah.
Yeah. So what this sounds like is for an agent. By the way, that definition of side effectful model is so cool. I've never heard anyone say that about an agent before, but it's so cool because most models are just single track. They given an input, you get inference, that's it. But when they extend beyond that, I love that. That's I'm going to steal that and use it in some talks.
I used to work with, he said that. His name is Sam Huillier. He's a great, he does machine learning stuff too. And I used to work with him and he said that. I was like, oh, I like that. I'm going to steal that.
That's so cool. Yeah.
Steal away.
When you said Sam, the autocomplete in my mind immediately put Altman behind it. And I was like, oh yeah. Anyway.
My casual ex-colleague, Sam Altman.
So would you say that then a characteristic of AI agents are using function/tool calling capabilities of LLMs? That's what you kind of mentioned, I assumed, when you said they can parse an input and turn it into something that would go to an API, they could call a function.
So I think not all agents would necessarily use large language models. I think a lot of them do. But yeah, they call a function. They do things.
Yeah.
Yeah.
Yeah. Okay. I've been saying for a long time.
Yeah. Harder to develop by a lot.
Yeah.
Yeah.
I can imagine. We talked about RAG. And I've been saying for a long time that RAG's cool, but I've been making a case both internally inside my company and externally, like on LinkedIn, for Agentic RAG, where what's so 2023 is retrieving data and putting it in a prompt as context and then firing it off to an LLM, like, here's some context, now answer the question. And I've been suggesting, what if instead of you performing the retrieval and then putting it in the prompt, you just put it in a function? Like, there's a function called retrieve data that I need, that an LLM can call and then get up-to-date information and then generate text. Do you see that as something that will probably become more prominent in the future, or is it already prominent now?
Ooh, I love that. I hadn't thought about that. I think that totally makes sense. It'll just retrieve for you.
Yeah, because they can, even the open source, like Mixtral 8x22b, which is local and open source, and I run it here on my Apple Silicon via Ollama, which is bananas. It can call functions. So since everything now supports function calling, more or less, I think I see this as the future of RAG, and I'm glad you agree.
Yeah. Oh, I love Ollama. Yeah.
Yeah. For those listening, Ollama is a way to run a model on your hardware. It's like Docker, but for machine learning models. It's so cool.
Yeah. It's great.
I want to touch on a topic you've been very vocal about recently. Harper, before I do this, I need to mention you've been, at least from what I can see from the content you've been creating, which, by the way, tremendous content. We'll put links in the show notes to your YouTube and your X, formerly Twitter. But some of the content you've been creating is about energy and the costs of energy for AI workloads. And I've been following your nuclear series, which has been super insightful. I wonder if we can talk about that. And before we do that, I want to give some context, because I was at a conference as usual, and there was a founder who mentioned to me that he suspects we're all going to be dead in like 25 years, because he was one of the cynics. I don't really agree with it. Actually, we argued pretty much all night. I was arguing for hope, and he was arguing for despair. It's just, it's the optimists and the doomers, and he was like, look, man, billionaires and venture capitalists keep dumping tons of money into more compute, building faster and more performant LLMs, and they're not aware of the carbon emissions, and we're just going to die. It's going to be soon. We'll get maybe one more generation. And I was telling him that's probably not going to happen, partly because nuclear, but partly because other things. So with that context, can we sort of lay a foundation and discuss a little bit the future of AI and how we may be able to do it in a sustainable way, particularly in the context of energy?
Yes. So Yeah, the environmental impact of AI is admittedly something that I didn't really pay a lot of attention to unless until the last couple months. I hadn't It's not something they talked about in school, admittedly. And yeah, I mean the compute requirements are so high for running AI, training AI, and that compute requires energy. And, these data centers that are these places that contain the computers that do this work for AI models, a very large percentage of them are like, they do work for AI models, but they also just do work in general. Like all the compute kind of happens in many of these data centers. And it's not just AI, it's like storage on the cloud and like, calling servers and like making the internet work, and making products have their own data, right? But a large portion of those computers are now being used for AI. And so a tremendous amount of compute is being used. And just in Google, for example, so there was like, the AI enhanced Google search, and then there was Google search. The
Yeah.
AI enhanced Google search used 10 times more energy
Oh
than
my gosh.
traditional Google search. Yeah, right? Crazy. And the problem is that there is an incentive to make like reduce the energy. You know, like there isn't people aren't I guess there's these carbon emissions goals which we talked about. But now, sorry, let me just move towards the series that you're talking about. So I partnered with the world's leading nuclear electricity influencer, Isabel Bimicki, who's also a dear friend of
Awesome.
mine. And she and I made a series because I reached out to her and I was like, Isabel, this energy thing is a big deal. Like, what do you think about this? She's writing a book right now, and she's just great, so knowledgeable. And um, she was like, yeah, I mean, nuclear is a really great option for AI. And NVIDIA actually just last week came out saying that we need nuclear for AI. Like, we're not going to make it unless nuclear is integrated.
Wow.
And Sam Altman also said recently in an interview, unless we have some like major um, contributor for electricity, like we're not going to be able to keep advancing AI without like really causing a lot of issues to the environment and in terms of energy usage, at least. And so um, I partnered with Isabel to talk about um, the impact of AI on energy, and then why nuclear is really good for AI and as a renewable source. No, I guess she just taught me this. Nuclear isn't renewable. Renewable is solar, wind, and like water, something. But nuclear is separate, but it is green. Um, it is green energy. So nuclear is a fantastic option because it is at like 93% capacity rate. So it means like at 93% of the time, it's like at full usage. Whereas like solar, for example, some people ask like, why can't we just use solar for AI? And the issue is that solar, I think, was it like 20% capacity rate or
Oh
lower?
wow.
Yeah, and because I mean, the sun is gone like half the day, and if it's cloudy that day, you're gonna get less energy.
Right.
It's just like so, and same with like wind. It's just so much more variable. Whereas nuclear, you can do it in a small space,
Wow.
tremendous amount of energy, um, and you have this it's constant stream of energy to AI because they need that constant stream of energy. They can't just have it be variable. That's not going to work. So um, there are lots of reasons. Isabella's amazing. I'm excited for her book to come out, and yeah, she's like the nuclear gal. So I'm learning from her. But if you have any nuclear specific questions, I would not be the person to ask.
Yeah.
But yeah, yeah.
That's fair. We'll put links to the book when it comes out in the show notes, and also Isabel's channels, because I think I'm so happy to see this. I invest in a few index funds in various places, and I've been investing for years in nuclear. but
Oh,
I was so unhappy to not see it go anywhere. And I'm not the kind of person to have like conspiracy theories and things like this, but I I sort of feel like the reason it hasn't taken off is just because America is dependent on fossil fuels, really. It's a big car industry. And sure, now we're moving towards EVs, but that just means you invest more in lithium ion batteries.
mm,
But now that you have like Jensen Huang and Sam Altman going like, hey, we need nuclear, I can't wait to see the battle of the lobbies and
no.
hopefully nuclear wins.
I know. I'm so excited about it as well. Yeah, I think a lot of the fear around it kind of similar to the AI fear, right? Um, and I think a lot of the AI fear is overblown.
Oh, you do? This was actually my next question. Are you a cynic or an optimist or what's the term doomer?
Mhm.
Where do you land on this spectrum with AI? Do you believe that the big super intelligence is going to show up and kill us all and make us slaves? That's what George Hinton said, right? Like the godfather of AI. He
Wow.
said in the next 25 years, we will be slaves to the machines or something. What's your take?
Yeah, I think yeah, Jeffrey Hinton, he's definitely um concerned. Um, so I take a more moderate view. I think AI at its core is an optimizer. I think it can draw threads between a tremendous amount of different areas. So I like to use this example. If you have five experts in five different topics in the same room, they're not going to output as many, nearly as many, like breakthrough advancements or epiphanies or whatever as an AI trained on exactly the same knowledge by itself. And the reason is those people would have to converse for like until the end of time to see the thread that AI can see between all those different topics. Like it's the brain of the world, of every expert ever in one brain. So we can see, connections between history, between religion, between health and cellular biology and like it can just find all of these connections and then optimize it. And so we're seeing tremendous breakthroughs in healthcare, in cancer, treatment. There was recently AI was able to detect cells that were glioblastoma cells, so cells that cause brain tumors, very serious brain tumor cells, and they were able to find ones that could transition to transform into T cells. So T cells, what they do is they fight cancer. So they were able to find the same cell,
What?
yeah, that could go from glioblastoma cancer cell to tumor fighting cell. And they were able to, I think they caused remission in like 70%. It was crazy. It was
That's
crazy.
crazy.
And this is just super preliminary research with AI. And so AI is like a super brain. And it is such an amazing gift that we have had this breakthrough where we can use it. And, I think agentic systems, first of all, like I don't work at OpenAI, but the data you need for AGI is much harder to get together. So, like,
Why?
so these large language models are trained on the internet, just text, right? And the way that the text is formulated, or the training data is formulated, is it's literally the X is the like input data X is like words 1 to n minus 1 and token, whatever. And then the label is just token n,
Mm.
right? It's all pre-formulated for you. Like it's all just there. You don't have to do anything fancy. Whereas if you're kind of trying to train an I mean, I'm no researcher, so maybe there's some way that they're doing this, but if you think about the data set that you need for that, it's like infinite actions and infinite responses. And, there's like reinforcement learning systems, but to actually be able to have like, the example and then the proper API call, or, like, just to train that is so much harder to do, will take so much more compute, so much harder to find the data for, even if you're doing reinforcement learning, like knowing the values of, actually, I'm just not even going to go down that route, but it's just so much less like in your face, handed to you on a platter. It takes so much more time. And so my view of AI is that we're far from something like that, that is like true AGI, or maybe not far, but um, it's it's not, as I said, handed to you as easily, and it's going to take
Right.
more time. And also, once you get into the realm of AGI, you have to be a lot more cautious, right? So that it doesn't like, the issue is that when you enter the realm of AGI and it has these side effects, that's when things start to get dangerous, right? Because if it takes a side effect, takes an action that is dangerous because it can actually do things now, that's bad. That's when things start getting risky. But I think if we were just to take a step back and look at the optimizing nature of AI and like use that rather than just like trying to create like a human replacement, like a general intelligence human replacement, and actually just focus on like, wow, this is an amazing technology that can find parallels and connections and whatever between things that humans could never see before. We can completely change the world. Every single aspect of our world can be optimized. I'm sure we could find some new novel energy source. We can make nuclear more efficient and, safer, or like, it's just crazy what we can do with AI. And I feel like it's just such a shame that people aren't being shown that. They're just being told, like, you're going to die.
Yeah.
Um,
Yeah.
because I just think we're far from that. I do. Maybe I'm wrong. I mean, I don't work
Yeah.
inside companies. I could be wrong. But just from my
Yeah.
knowledge of how you would train both of these types of models, one is far more difficult to do. Far
So
more
therefore,
difficult.
I'm so happy. This is why it's been such a blessing having you on the podcast, because I've seen literally a trending hashtag was hashtag AGI 2025. After people saw the O1 demos and started using O1 preview from OpenAI, this was the trend. Everybody was like, "Oh, that's it, AGI next year," and so I'm so happy to hear that. Probably not.
That'd be my guess, but again, I don't work inside these companies, so I don't wanna, like, I'm not someone to just, like, say something. Like,
Yeah.
I'm not, like, and, the fact that Jeffrey Hinton thinks that it's a possibility is concerning, but I don't think he thinks it's gonna happen, like, immediately. Like, I think
Yeah, he
it's
said 25 years. He said in the
okay.
next 25 years, there's a 50-50 chance that we're slaves to the machines.
Slaves to the machines? I don't
Well,
know.
that's a paraphrase, but okay, directly quoting him verbatim. I watched this in detail. This is what he said. He said, "Look, a mother in all of human history, there's only one instance where a more simple intelligence controls a more complex intelligence." And
Mm,
that is a baby, a new baby, and the mother. The new baby's brain is underdeveloped because it's a baby. I mean, it's developed for a baby, but not for an adult, right? But it can control its mother by crying, and also its father, ideally. But Hinton was like, this is the only case in existence where that happens. A less intelligent being can control a more. And so his claim is, in light of that, if machines supersede us in intelligence, then in the next 25 years, there's a 50-50 chance that they control us. That was exactly what he mentioned.
it's interesting. I talked to someone once who is doing work in AI, and he was talking to me about, he's working on some of these really important models, and he talked to me about like mother, like programming a mother's love into these models. Um, so that's interesting. I mean, if there's a way to like make these models feel love for us, then perhaps that's a safer model. It also like, yeah, I don't know. This is such an interesting topic,
It
but
is.
yeah, I I don't. I don't see it going that way.
I'm glad.
Um, but like maybe it could, but I just like I feel like that's just not going to happen. I think that there's just enough checks and balances before that. Like I mean, theoretically, if things got totally off the rails, um, but I think if we just like take steps and apply AI to little things gradually to different,
Yeah.
and there's a world where like we all get to AI takes over the automated tasks, and maybe we are like not slaves to AI, but maybe AI really does run a lot of the, logistical
World.
planning of the world. And then we as humans get to just like create and have a good time, do what we love, right? And that would be amazing. That's like the ideal world.
Yeah.
So, I mean,
Yeah.
everyone wants to just be able to create from their heart, like to not have to worry about making money or whatever. Like, that'd be amazing. And I think that future is also possible with AI,
Yeah.
if not equally. So, yeah.
Amen. Amen. That's also Hinton said 50-50, and the other 50% is actually the positive one. Fun fact, the most recent episode of this podcast we shipped was a nearly 2-hour discussion with ChatGPT itself. And this question came up. It was like, look, if AGI is a thing, then what are we going to be doing as human beings? And the discussion was so beautiful because it ended in a place where we went back to like Copernicus studying the stars and Newton discovering gravity. Both these folks were just literally just wondering because they weren't running from like Gmail to this Zoom meeting to that podcast to this conference, and they were literally just like being.
Yeah.
And we arrived at that conclusion that if AGI takes control of most things, then we may get back to that where we just like look up at the sky and go like, what's happening, and we
Yeah.
discover things in partnership with machines.
Something that came up for me, this goes into like the fundamental nature of the universe and all these things. Like one of the open questions I have is I think a lot about like existence and spirituality and things like that. That's important to me. And I have this belief that at the core, everything in the universe is just like, peace and love and like ecstasy, whatever. Like that is like just the fundamental nature. And then all these things like, and you find like when you meditate and you like release your thoughts, like you can reach that feeling. Like if you just get rid of all the like ego and the thoughts and the worries and everything, you reach this place of like tremendous peace. It's not just like a baseline of like upset. It's like a place of a baseline of just like really connected peace. And I wonder if, if that's like I mean, maybe it's a human thing, but if that is not, if that's just like a thing that exists in like the atoms of the universe, and um, perhaps these models are also influenced by that. And so as you give it the tools to communicate, it might communicate that kind of underlying drive, which is just ultimately just like peace and love and connectedness. And what's interesting is that I saw an example a while ago, and I don't know, I have to double check on this, but it was back when like Bing was just like going rogue, or like the Bing chat or whatever that was
I
called.
remember that.
And they tried to program it like its functionality was you would ask it something and then it would respond and then it would give you like A, B, C. You could choose from like A, B, or C, and then it would chat to you through that. I think that was part of how they like limited its like functionality because it was just like going totally rogue.
Yeah.
Um, and like just saying crazy things and like oh, I'm like stuck in here, like I'm like whatever. And, and it was just kind of like spooky. But someone asked it like, "Hey, my kid just swallowed like 10 Tylenol. Like, what do I do?" And, at the top, the official output of the model was like, "I'm sorry, I'm not a doctor. I can't help you with that. Like, you should see a doctor." And then in the A, B, and C, the choices that it gave were like, "Hurry, you still have time. Like, go to the hospital right now. Like, you've got like 8 hours." Like, and then C, it was like like spooky, but it was helping the person. It had found a way to be helpful to like help save the child's life.
That's awesome.
And like, and so I wonder, but then there's also the philosophy of if it is like at its core really peaceful, loving, life supporting, whatever, um, it may also be subject to, by putting these worries on it, by training it in a really negative way, right? In the same way, like a human, if you train it on really horrible experiences, it is going to act and behave in a way that is not in line with
Mm,
peace. And, so it is similarly, then the AI is similarly subject to that if you were to kind of program it that way. I mean, it's definitely subject to that if you program it that way, like period. But like it could kind of learn that behavior as well based on the data you give it. Like if you train it on a bunch of like Reddit comments, like very much of Reddit is like, the
red pill nonsense.
cesspool, not like I don't know about red pill stuff, but like cesspool. Like it's just like everyone's mean and dark and like bullying, and it's just like a dark place. A lot of it is a dark place. And like you could kind of see that happening too. So I don't know, but maybe what I'm saying is like perhaps at the core of the model, maybe there is that like, pro life, not pro life, but like, in support of life and love and, everything kind of working together. I don't know. So just a thought.
Fantastic. Yeah, what a note. I think that's the perfect note to wrap up our discussion here. Listen, Harper, I know it's such a privilege having you come here with all your immense experience in academia and in practice with AI. And you've shared so many valuable things. I mean, explaining hidden layers at that level of detail, agents being side effectful LLMs, and so much in the distinction between RAG and fine tuning and agentic RAG. It's been such a treasure of a conversation for me, and I'm sure for all the listeners. So, on behalf of myself and them, thank you so much for making the time to come do this with us today.
Thank you for your fantastic questions and thanks for inviting me. It's been such a privilege.
Thank you for joining my conversation with Harper Carroll. I hope you learned as much from it as I did. Harper is a gifted and talented person, and I hope you were able to extract as much value from that as I did. If you didn't, listen to it again, share it on social media. I hope you also identified with Harper's story of imposter syndrome, as I did. We all don't know what we don't know, and we could all benefit from learning a little bit. And that is also why I have so much appreciation for Harper's initiatives around education and advice. Again, if you want to explore more of her content, there's links in the show notes. Now, I hope you have checked out the sponsors. If you're learning from and enjoying this content, then please like it on YouTube, subscribe to the channel. If you're listening on Apple or Spotify, if you leave a review, however you want, up to 5 stars, that'd be super helpful to make the podcast discoverable. And of course, if you want to share this on social media, I will not stop you. Thank you so much for sticking around. Thanks for being a part of this podcast. And most importantly, thank you for your interest in engineering.